Hi everyone. This video is to read aloud some of the content that we're going to learn with the Exploring Fronts assignment. So this is the Exploring Fronts website that I want you to use to complete the assignment. So when you first click on the link, this is what you're going to see. And right now I am in Google Chrome. You may choose to go into Internet Explorer. That might work as well. But one thing we want to do is click on this puzzle piece so that it will play. I've tried this before. It's going to work here. It should work in Google Chrome for you. So I'm going to click on this. I need to press allow at the top. And once I do that, this is what you should see on your screen. So notice we have some content at the top. One thing that I'm going to do is zoom in. So this is a little bit bigger because right now these words are pretty small. Few ways you can zoom in. One way is to find the 3 vertical dots on the top right. And we can zoom in here. We should be at 100%. I'm going to keep going. Maybe 125 might be okay. I'm going to stop at 150. So it's a little bit easier for me to read. Okay, so this is what my screen looks like. And first thing I want you to do is read the introduction at the top. So I'm going to read that out loud for you. All right, so here I go. I'm going to read the introduction. A weather front is the area where 2 air masses with different temperatures and densities collide, but they do not mix. The collision often causes storms and changeable weather. There are 4 types of fronts: cold fronts, warm fronts, stationary fronts, and occluded fronts. In this activity, in this active art, you will have a chance to I can scroll here. You will have a chance to explore what happens at each front. Click on one of the 4 types of weather fronts to begin. Okay, and that's it. So I'm going to click on cold front. So on the left, we can see our 4 different front types. And right away, it starts to play and show you what happens. So make sure we're looking at that. I can play that again. I can take my little scrolling item, go back, then I can press play if I wish to play it again. So as we can see, we have cold air meeting warm air, and since the cold air is denser, it's heavier, it slips underneath the warm air and pushes it up. And when the warm air goes up, it will start to condense since it's a little bit colder up here, and then you're going to have clouds and weather. So at the top here, we have some information, so I'm going to read that out loud to you. A cold front occurs when a rapidly moving air mass runs into a slowly moving warm air mass. Because cold air is denser than warm air, the cold air mass remains close to the ground and sinks under the less dense warm air mass. As the warm air rises above the cold air, the warm air cools. It soon chills to the temperature at which water vapor in the air condenses into droplets of liquid water. Towering cumulus and cumulonimbus clouds form from the drops of water produced by the rapid rise of warm air. Because cold fronts move quickly, they can cause abrupt weather changes. Strong winds and severe thunderstorms are often linked to cold fronts. If there is enough water vapor in the warm air, heavy rain or snow may fall. But if the warm air contains little water vapor, the cold front may be accompanied only by cloudy skies. Okay, we are done with cold front. Now on the left, I'm going to click on warm front. And notice you can go back each time. And we have new information to read and something new to observe with our warm front. So it looks like they're going in the same direction. And again, since warm air is less dense, it's going to go on top. And we start to see some weather happening, just like we did before. Okay, so I'm going to turn my attention to the description of warm fronts at the top. So it looks like you can also make this a little bit bigger as well. Okay, at a warm front, a slowly moving warm air mass collides with a slowly moving cold air mass. Because cold air is denser than warm air, the warm air rises over the cold air. Clouds, storms, and rain often accompany warm fronts. If the warm air is dry, scattered clouds form. If the warm air is humid, showers and light rain fall along the front where the warm and cold air meet. Because warm air fronts move more slowly than cold fronts, the weather may be rainy or foggy for several days. Okay? And again, you can play this over. You can pause it, press play, fast forward at different parts, however you want to do it. But I would make sure I would look at this first and then read the description or listen to it. Okay, our next type of front, on the left, I'm going to click stationary front. I'm just going to pause it and let's look and see how this looks different from our other two fronts. So let's press play. So going in the same direction. Okay, and we have precipitation forming. Okay, a stationary front. Sometimes cold and warm air masses meet, but neither one has enough force to move the other. The two air masses face each other in a standoff. In this case, the front is called a stationary front. Where the warm and cool air meet, water vapor in the air condenses into rain, snow, fog, or clouds. A stationary front can remain stalled over an area for many days. Last but not least, we have an occluded front. So let's take a look at what's happening here. Again, we have at each type of front, we have some sort of, at minimum, we have some clouds, and usually we have precipitation, snow, sleet, rain, okay, but every time we have clouds that form, okay, when these two different air masses meet. Okay, so I'm going to read at the top again, occluded front. The most complex weather situation occurs at an occluded front. At an occluded front, warm air mass is caught between two cooler air masses. The denser cool air mass moves underneath the less dense warm air mass and pushes it upward. The two cooler air masses meet in the middle and may mix. The temperature near the ground becomes cooler. The warmer air mass is cut off or occluded from the ground. As the warm air mass cools and its water vapor condenses, the weather may turn cloudy and rainy or snowy. Okay, so this is our types of fronts website. So we are done reading that. There is a couple things back on the document. This will be a little bit further down the page. So this is just to show you what a weather map looks like. So here we have cold fronts. Okay, so cold fronts, we use the blue triangles. Warm fronts are the half dots. So the red half circles, sorry. L means low pressure. Okay. Okay. So I'm going to pause it here. If you need to go back, you may do that and you can replay each simulation. Okay?